Right, hello again. Right, this one is the second part of our lesson 16, and it is on graphs and things again. No, it isn't. The first part was on graphs. This bit is going to be the probability. Oh. Oh. Probability. It's not going to be all of the probability. It's just going to be the actual part that we did in lesson 16. So, what did we start off with? We started off with a number line. And the number line looks like this. And it has 1 at that end and 0 at the other. It always goes to 1. 1 is everything. 1 is 100%. 1 is all. Yeah? Now, if you've got a 0, you're down at this end, and you think, what's the probability there of something happened? You've got 0 probability, so this is going to be impossible. And up here where you've got 1, it's certain. In the middle, it's going to be even. And the probability of something that's even could be described as a half, or 50%, or 0.5. Yeah, and then you've got down here, which is about a quarter. So you've got a quarter, 25%, 0.25, and this is going to be unlikely. Up here, 3/4, 75%, and 0.75. And this is going to be likely. And they may, in a question, give you an event, and you have to put it on the number line. Decide whether it's going to be likely or unlikely or otherwise. Now, okay, that's that. Next sort of probability we looked at was just something out of something else. So we did 200 people in a room, and 150 are wearing red. Now, we had to say about the probabilities of what's the probability, and this is how it's written: P for probability, and then an open bracket, and the words or the what we're after, the probability of being able to go into that room without looking, touch someone on the shoulder, and know if they are wearing red or not. So the probability of that happening would be 150, because they are 150 over 200. Yeah, so it's what you're after over, so what you're looking for over everything. So what you're looking for over everything. So you can simplify this if you want to, but there is a danger if you simplify this, you may make a mistake. I think this is going to be okay. So I'll do 15 over 20, 5, 3 over 4, 3/4. Now what's the probability of not picking someone in red? Now we know there are 150 people wearing red, so there must be 50 people that are not wearing red, and it's still out of 200. So that would be 5 over 20 if I simplified it. Now, the next thing we did is this will be working up towards probability trees, yeah? So we had a little bag like this, and in the bag there were 10 red counters and 5 blue counters. And this is a bit like pulling out the balls for the FA Cup draw or something. You put your hand, swish it around and pick a ball out and see what colour it is. So when you've got 10 red and 5 blue, the probability of picking a red one, a red, will be equal to 10 out of 15. And I'll leave it like that, yeah? And the probability of picking a blue one would be equal to 5 out of 15. Now, imagine that was pick one. So you've got two choices, yeah? You can either pick a blue or you can pick a red. Now, if you sort of moving on to trees almost, yeah? So if you now want to know the probability of picking a second red, now what you're going to do is take the counter and keep it. Okay, so what you've done, if you follow this road up there, you've taken a red, and now you've got a 10 out of 15 chance of doing the red, and now you're going to take another red. Now there is one red that you've taken out, so there are now only 9 red balls left in the bag. And because you've taken a red out and put it in your pocket, there's only 14 altogether left in it, so it's 9 out of 14. And the probability of doing a blue is you've taken a red one out. There are still 5 blue ones in there, but again, because you've taken a red one out, there's only 14 left. And here the probability of a red, and here the probability of a blue. So we've taken the blue out. Now there are still 10 red ones in the bag, but there are only 14 altogether because you've taken a blue out. Here we're going to go blue followed by blue. So you take a blue out, and now there's only 4 blue ones left out of 14. So that's two independent probability. No, yeah, it's two independent probabilities. It's picking a ball once, then picking a ball the second time. And if you take these numbers here, 9, 5, 10, no, we'll leave that for the probability tree thing. I was going to multiply. These are what the probabilities are. So these are the probabilities of the individual events, not the combination of probabilities. That will come later. So next. So let's have a dice. And we've got all the numbers on there, 4, 3, 2. Yeah. The probability of rolling a number 4. Now, there is only one number 4 on there, so you've got one chance. But there are 6 sides, so it's 1 out of 6. Now, take a second dice, and you've got 4, 3, 2. Again, the probability of rolling a 4 on that second dice is 1 out of 6. Now, if you want to throw both dice together, or one after the other, and you want to get a double 4, you know that that is going to be 1 out of 6 on the first one and 1 out of 6 on the second one. And when you have multiple probabilities, you multiply them together. So the probability of getting a double 4, or a double anything really, is going to be 1 out of 36. Yeah. So you can see it's much more difficult to get a double than it is to get a single number. Then we talked about spinners. Yeah, a spinner is like I don't know, piece of cardboard with a pencil stuck through the middle, and you have all these divisions, 1, 2, 3, 4, and you spin it round, and where it lands, that's the number you got. So this is multiple events. Okay, so we're going to have two spinners, that is, spinner A and spinner B. And one, two, three, 4, and 2, 4, 5, 10. Okay, so you will be given like a little table like this, and this is the score from spinner A. So spinner A, you got 2, 4, 5, and 10. This is spinner A, and spinner B is 1, 2, 3, and 4. And I'll colour that in because it's nice to colour things in. Okay, spend too much time on this. Right, so what we're going to do now is we're going to spin both A and B and add the scores together. Now all this will be printed in the exam, the spinners and the chart, and your job is to fill in the chart, right? So if you get a 2 on A and a 1 on B, adding them together will give you 3. 4 and 1, 5, 5 and 1 is 6, 10 and 1 is 11, 2 and 2 is 4, 2 and 4 is 6, 2 and 5 is 7, 2 and that is 12. We get in there. 3 and 2 is 5, 7, 8, 13, 6, 8, 9, and 14. Okay, now here's the question. The first part is complete the table. The second part will be what's the probability of you getting an odd total? And what's the probability of getting a number 7 as the total? So we've got two questions down here, so let's move up a little bit. So, an odd. So the probability of an odd is count all the odd numbers, which is 1, 2, 3, 4, 5, 6, 7, 8, 8. So there are 8 odd numbers out of 4 fours are 16, which you could simplify as 4 over 8, 2 over 4, 1 over... Yeah, simplify that to be a half. Now 7, there are 2 7s, so that's just going to be 2 out of 16 or 1 out of 8. Here's another little table. Let's try and make things so that we can see. Okay, so we've got another table which is 4 by 3. So we've got 4 by 3. Cut that in half if we're doing 4. Half again. And 3, we want this. Okay, so this column is the age of people. This column is if they're married. And this is unmarried. unmarried. Should have put single there, didn't I? Unmarried. And this will be the total of something. And there'll be another total as well then. So the age is under 30, over 30, and we've got 562,159,721. So you see the under 30s, you've got 500 odd married, then the unmarried, add them together, you get a total in the right hand column. And so this one is 821, 1213, and 2193. Oh, say, complete the table. Right, so complete the table. Let's turn a different color. So we know this one, and we know this one. So 1213 subtract 562 will be 651. Now we can get this one because we can go 651 plus 821 is 1472. Now what have we got? This one and this one, if we add together, we get 980. So we need some probabilities, yeah? So an over 30 is picked at random. See what the question is, I can't remember. Let's go back to try and manipulate this. So an over 30 is picked at random. What's the probability that they are married? Now, what we're going to do is the over 30s, married people. So that will be 651 over 30 people are married out of 1472 because we're only looking at the over 30s. 1472. Right, last question, which is just a tiny little question, but it's so tricky. Yeah, everybody is a bit of a nightmare on this one. 3, 1, 7, 10. Just 4 little numbers, yeah? And so we've got vegetarians and non-vegetarians, yeah? And we've got those who have an allergy and those with no allergy. Allergy. So you've got allergies. So you've got 3 vegetarians have an allergy, 1 non-vegetarian has an allergy, 10 vegetarians have no allergy, and 7 non-vegetarians have no allergy. There are 13 vegetarians altogether. There are 8 non-vegetarians altogether. There are 4 people that have allergies, and there are 17 people that don't have allergies. So, every possible question now. What's the probability that a vegetarian has an allergy? Let's have a look. So we need all the vegetarians, which are 13, and 3 of them have an allergy. Therefore, that will be 3 out of 10. What's the probability that you pick a vegetarian at random? Yeah, all these people gather together and they don't tell you what they are, and you pick one out. Now, how many vegetarians are there? There are 13. How many people are there altogether? There are 21. Yeah. Now, what's the probability that a non vegetarian has no allergy. A non-vegetarian, there are 8 of them, and there are 7 which don't have an allergy, so it's 7 out of 7 allergies, 7 no allergies out of the non-vegetarians, 7 out of 8. And the last one, what's the probability that someone with an allergy someone with an allergy who is a non-vegetarian. Okay. So someone with an allergy. That's all these lot of the top 3 and 1. There was also a non-vegetarian. So there was only one non-vegetarian that has an allergy. So there's 1 out of all the vegetarians, all the allergy sufferers is 4. So someone with an allergy is 4 of them, but the probability of someone with an allergy is a non-vegetarian is only 1 out of 4. And that, I believe, yes, indeed it is. So let's go back to there. That is